Hello everyone, welcome to my first video on YouTube. I hope you all find it useful and learn something new in this video. Today I am going to talk about how to find the determinant of a 3x3 matrix. 3x3 matrix means that we have 3 rows and 3 columns. And we are going to find the determinant of this matrix. Det of the matrix A means that we are going to find the determinant of the matrix A. And as you are seeing here, we exactly use the same marks as we use when we want to find the absolute value of something, but actually it's something like the absolute value marks, but it doesn't mean the same here. Now I'm going to show you how we calculate the determinant of this matrix. First of all, I have to say that we take the first entry, the entry A sub 1 1, and multiply it by the matrix of ignoring of the first row and the first column. That we are left with. The first row and the first column. Okay, now ignoring these columns and row. And what we are left with is A sub 2 2, A sub 2 3, A sub 3 2, and A sub 3 3. And just after that we change the sign, which it was positive and now it is negative. And we take the second entry, the entry sub 1 2, and multiply it by the matrix of ignoring of this first row and second column. Ignoring of the first row and second column. And we are left with A21, A23, A31, and A33. Again, we change the sign, which it was negative and now it is positive. And we take the entry A sub 1 3 and multiply it by the matrix of ignoring of the first row and third column, which is A21, A23, A22, A31, and A32. And I assume that you already knew how to find the determinant of the matrix 2 by 2. But by looking at here, I again tell you that we multiply the top left entry by bottom right entry and subtracted by top right entry multiplied by bottom left entry. And again, as you are seeing here, this is the basic form of finding the determinant of a 3x3 matrix. And now by looking at the example here, everything would be much more clear for you, and I hope you understand what I mean. Okay, and here is the example, the matrix A, and we need to determine the determinant of the matrix A. Okay, we want to calculate it now. We take the first entry A sub 1 1 and multiply it by the matrix of ignoring of the first row and the first column, and the first row and first column, which we are left with 2 1 5 6. And we change the sign and we take the second entry A sub 1 2 and multiply it by the matrix of ignoring of the first row and second column, which is 3 1 1 6, and we again change the sign, which is and multiply the value of the third entry, entry A sub 1 3, which is 2, multiplied it by the matrix of ignoring of the first row and third column, that we are left with 3, 2, 1, 5, and now we only need to calculate it. Okay, 4 multiplied by 2 multiplied by 6 minus 1 multiplied by 5, which is equal to 7 multiplied by 4, we left with 28. Okay, here is negative multiplied by another negative, which is positive. Positive, okay? 5 multiplied by 3 multiplied by 6 minus 1 multiplied by 1, which is 18 minus 1, which is 17. And 17 multiplied by 5 is equal to 18. 5 plus 2 multiplied by 3 multiplied by 5 minus 1 multiplied by 2, which is 15 minus 2, which is equal to 13, and 13 multiplied by 2, which is gonna be 26, and by adding these final values, we get to the answer, which is 139. Hello everyone, today I'm going to show you how to find the determinant of a 3x3 matrix quickly. Here's our matrix A, and we need to find the determinant of the matrix A. In this method, we are going to use a formula which is equal to fraction, and our denominator is entry A sub 2, and our numerator is like this. All we need is to find the entries of B sub 1, 1, B sub 1, 2, B sub 2, 1, and B sub 2, 2. B sub 1, 1 is equal to the determinant of this part of our matrix. B sub 1, 2 is determinant of this part of our matrix. And B sub 2, 1 is equal to this part of our matrix. And A sub 2, 2 is equal to the determinant of this part of our matrix. B sub 1, 1 is equal to A11 multiplied by A22 minus A12 multiplied by A21. Entry B sub 1, 2 is equal to the A sub 1, 2 multiplied by A23 minus A13 multiplied by A sub 2, 2. And entry B sub 2, 1 is equal to A sub 2, 1 multiplied by A sub 3, 2 minus A2, 2 multiplied by A3, 1. And entry B sub 2, 2 is equal to A sub 2, 2 multiplied by A sub 3, 3 minus A sub 2, 3 multiplied by A sub 3, 2. And here's the example. This is our matrix A, and we need to find the determinant of this matrix. First of all, we need to find our entries. Entry B sub 1, 1 is equal to the determinant of this part of our matrix, which is 2 multiplied by 4 minus 3 multiplied by negative 5, which is gonna be 8 minus negative 15, which is equal to 23. Entry B sub 1, 2 is equal to the determinant of this part of our matrix, which is negative 5 multiplied by 1 minus 2 multiplied by 2, which is gonna be negative 5 minus 4, which is equal to negative 9. The entry B sub 2, 1 is equal to 3 multiplied by 5 minus 2 multiplied by 1, which is gonna be 15 minus 2, which is 13. And entry B sub 2, 2 is equal to the determinant of this part of our matrix, which is 2 multiplied by 6 minus 1 multiplied by 5, which is gonna be 7. And the determinant of the matrix A is equal to the determinant of this matrix here over A sub 2, 2. A sub 2, 2 here is 2, And the determinant of this matrix is gonna be 23 multiplied by 7 minus negative 9 multiplied by 13, which is gonna be 161, minus negative 117, which is gonna be overall 278 over 2, and we get to the same answer as we get to it in the previous video, 139. Okay, here's the question. What if entry a sub 2 was 0? In this case, we need to change our rows with another row which the middle entry is not 0. For instance, the determinant of the matrix A is equal to the determinant of the matrix of changing the first row and second row. And we are assuming that entry A sub 1, 2 is not 0. And we all need to multiply it by a negative. And all the same here. If we change this row and find the determinant and multiply it by negative, it's gonna be the determinant of the matrix A. Okay, now what if entry A sub 1, 2, A sub 2, 2, and A sub 3, 2 were all 0? In this case, the determinant of the matrix A is gonna be 0 because we have a column which all our entries in this column is 0. And we already knew that if we have a row or a column which our entries were 0 in the column or in the row or in more columns or more rows, the determinant of the matrix is gonna be 0. Hello everyone, and today we are going to look at the other way of finding the determinant of the 3 by 3 matrix. Is called Sarris Rule. This is our matrix A here, and we need to find the determinant of the matrix A that contains these following elements: A sub 1, 1, A sub 1, 2, A sub 1, 3, A sub 2, 1, A sub 2, 2, A sub 2, 3, A sub 3, 1, A sub 3, 2, and A sub 3, 3. In this method, we rewrite the first and second column. Here at the end, A sub 1, 1, A sub 2, 1, A sub 3, 1, the first column, and the second column, A sub 1, 2, A sub 2, 2, A sub 3, 2, okay? We need to multiply our values, our entries in these diagonals, and by adding them up and subtracted it by the multiplied of our entries in these diagonals, we can get to the answer, okay? The first diagonal, A sub 1, 1 times A sub 2, 2 times A sub 3, 3 plus A sub 1, 2 times A sub 2, 3 times A sub 3, 1 plus A sub 1, 3 times A sub 2, 1 times A sub 3, 2 minus A sub 1, 3 times A sub 2, 2 times A sub 3, 1 minus A sub 1, 1 times A sub 2, 3 times A sub 3, 2 minus A sub 1, 2 times A sub 2, 1 times A sub 3, 3. And here's an example. Okay. Determine the determinant of the 3 by 3 matrix below. We have the matrix A that contains these following elements: 4, negative 5, 2, 3, 2, 1, 1, 5, 6. Okay, we rewrite the first and second column over there: 4, 3, and 1. And again, the second column, negative 5, 2, and 5. Okay? We multiply our entries in these diagonals, and by adding them up and subtracted it by the multiplied of our entries in these diagonals, we can get to the answer, okay? The first diagonal, 4 times 2 times 6 plus negative 5 times 1 times 1 plus 2 times 3 times 5 minus 2 times 2 times 1 minus 4 times 1 times 5 minus negative 5 times 3 times 6. Okay? Here we have 4 times 2 times 6, which is gonna be 48 minus plus minus 5 times 1 times 1, which is gonna be negative 5 plus 2 times 3 times 5, which is gonna be 30, overall 73. Okay? And here we have 2 times 2 times 1, it's gonna be negative 4 plus 4 times 1 times 5, and we have a negative here, which is gonna be negative 20 plus negative 5 times 3 times 6, which is gonna be 19, and we have another negative here, so it's gonna be positive. Really, it's gonna be 66. So 3 plus 66. Get to the answer, which is gonna be 139. Hello everyone, in today's lesson we are going to find the inverse of a 2 by 2 matrix. We suppose that we have a matrix A which is 2 by 2 with these following elements: A, B, C, and D. A power negative 1 means that we are going to find the inverse of the matrix A. This is how we show it. And there is a formula for finding the inverse of a 2 by 2 matrix, which is equal to 1 over the determinant of the original matrix here, which is A, multiplied by another matrix. Okay? How we find this matrix? It's easy. All we need to do is just switching the position of our entries in this diagonal. So if it is A and D, so it's gonna be D and A. Okay? But about this diagonal, we keep them in the same position, but we just switch the sign. So if it is B, it's gonna be negative B, and if it is C, it's gonna be negative C. And you already knew how to find the determinant of a 2 by 2 matrix. But I'm gonna say it here again. Actually, you all need to multiply your values in this diagonal and subtract it by the multiplier of your entries in this diagonal. So it's gonna be A times D minus B times C. Okay? Like all the time, here's an example. Find the inverse of a 2 by 2 matrix below. This is our matrix A with these elements: negative 4, negative 3, 1, and 5. So, first of all, we want to find the determinant of this matrix. So we have negative 4 times 5 minus negative 3 times 1, which is equal to negative 20 plus 3 is overall negative 17. According to this formula here, we have A power negative 1 is equal to 1 over negative 17. Actually, the determinant of our original matrix, which is negative 17, times this matrix. How we find this matrix? We are going to find it, okay? We switch the position of our entries in this diagonal. So it's gonna be 5 and negative 4. It was negative 4 and 5, so it's gonna be 5 and negative 4, okay? But about this diagonal, we keep them in the same position, but we just switch the sign. It was negative 3, so it's gonna be 3. And it was 1, so it's gonna be negative 1. And you can also write it like this and multiply this, actually 1 over negative 17, with your matrix. So you have 5
over negative 17, 3 over negative 17, 1 over negative 17, and 4 over negative 17. Thanks you. So you have 5 over negative 17, 3 over negative 17, 1 over 17, and 4 over 17.
Hello everyone, in the previous video you learned how to find the inverse of a 2 by 2 matrix, and in this video we are going to take a look at the way of finding the inverse of a 3 by 3 matrix. We suppose that we have a matrix A with its following elements: A sub 1 1, A sub 1 2, A sub 1 3, A sub 2 1, A sub 2 2, and A sub 2 3, A sub 3 1, A sub 3 2, and A sub 3 3. There is a formula for finding the inverse of a 3 by 3 matrix, which is equal to 1 over the determinant of our matrix times another matrix, which is called the adjoint of the matrix in linear algebra. We suppose that this matrix is called B, so our following elements are gonna be B sub 1 1, B sub 1 2, B sub 1 3, B sub 2 1, B sub 2 2, B sub 2 3, B sub 3 1, B sub 3 2, and B sub 3 3. Okay, how do we find our elements? For instance, here B sub 1 1 is equal to the determinant of the matrix of ignoring of the first column and the first row that we are left with, which is A sub 2 2, A sub 2 3, A sub 3 2, and A sub 3 3. The entry B sub 1 2 is equal to the matrix of the determinant of our matrix of ignoring the first column and the second row. So it's gonna be A sub 1 2, A sub 1 3, A sub 3 2, and A sub 3 3. Okay. The entry B sub 1 3 is equal to the determinant of our matrix of ignoring of the first column and the third row, which is equal to A sub 1 2, A sub 1 3, A sub 2 2, and A sub 2 3. The entry B sub 2 1 is equal to the determinant of our matrix of ignoring of the second column and the first row that we are left with, which is equal to A2 1, A2 3, A3 1, and A3 3 here. The entry B sub 2 2 is equal to the matrix of ignoring of the second column and the second row that we are left with, which is equal to A sub 1 1, A sub 1 3, A sub 3 1, and A sub 3 3. The entry B sub 2 3 is equal to the matrix of ignoring of the second column and the third row that we are left with: A sub 1 1, A sub 1 3, A sub 2 1, and A sub 2 3. And entry B sub 3 1 is equal to the matrix of ignoring of the third column and the first row that we are left with, which is gonna be A2 1, A sub 2 2, A sub 3 1, and A sub 3 2. And entry B sub 3 2 is equal to the determinant of the matrix of ignoring of the third column and second row that we are left with, which is gonna be A sub 1 1, A sub 1 2, A sub 3 1, and A sub 3 2. Okay. And entry B sub 3 3 is equal to the determinant of the matrix of ignoring of the third column and the third row that we are left with, which is equal to A sub 1 1, A sub 1 2, A sub 2 1, and A sub 2 2. Okay, that's all we need to do. And about the signs, we know that the first entry is positive, and from here we change the sign. For instance, here is positive, so it's gonna be negative. Positive, negative, positive, negative, positive, negative, and positive. Okay. And here is an example. Find the inverse of the 3 by 3 matrix below. We have a matrix A with these following elements: 0, 1, 2, 4, 3, negative 1, 2, 0, and negative 3. First, in the first step, we need to find the determinant of this matrix, and I'm going to use the quick method, okay? So we find the determinant of this part of our matrix, which is 3 times 0 minus 1 times 4, which is negative 4 here. And
Then we find the determinant of this part, 1 and minus 6, which is gonna be negative 7, okay? Then we find the determinant of this part of our matrix, which is 4 times 0 minus 2 times 3, which is gonna be negative 6, okay? Then we find the determinant of this part of our matrix, which is gonna be 3 times negative 3, which is gonna be negative 9 minus 0, which is gonna be negative 9 overall, over our middle entry, which in here is 3, okay? Then we find the determinant of this matrix, negative 4 times negative 9 minus negative 7 times negative 6, which is gonna be 36 minus 42 over 3. So the determinant of our 3 by 3 matrix is negative 2. By using this formula, we have here 1 over the determinant of our matrix, which is negative 2, times the adjoint of this matrix. How do we find the adjoint of this matrix? Let's find it. Okay, the first entry is equal to the determinant of the matrix of ignoring of the first column and the first row that we are left with, which is 3, negative 1, 0, and negative 3, okay? And the second entry is equal to the determinant of the matrix of ignoring of the first column and the second row, actually, that we are left with. 1, 2, 0, and negative 3, okay? And the next entry is gonna be this, 1, 2, 3, and negative 1. And entry b sub to 1 is equal to the determinant of the matrix of ignoring of the second column and the first row, which is equal to 4, negative 1, 2, and negative 3. 4, negative 1, 2, and negative 3, okay? And the next entry is gonna be 0, 2, 2, negative 3. Okay, and the next entry, 0, 2, 4, negative 1. 0, 2, 4, and negative 1, okay? The entry b sub 3, 1 is equal to the matrix of the determinant of the matrix of ignoring of the third column and the first row, which is gonna be 4, 3, 2, 0, okay? And the next entry is gonna be 0, 1, 2, 0, 0, 1, 2, 0, and next entry 0, 1, 4, 3, 0, 1, 4, 3. And about the signs, we know that the first entry is positive and we change the signs. So it's gonna be positive, negative, positive, negative, positive, negative, and positive, negative, and positive here, okay? The determinant of this matrix is 3 times negative 3 minus negative 1 times 0, which is negative 9, okay? And here 1 times negative 3 minus 2 times 0, and we have another negative here, so it's gonna be negative, negative 3, so it's gonna be 3, okay? And here we have 1 times negative 1 minus 2 times 3, which is gonna be negative 7, and here 4 times negative 3 minus negative 1 times 2, which is gonna be negative 10. Actually, we have another negative here, negative 10 is gonna be 10. And here we have 0 times negative 3 minus 2 times 2, which is gonna be negative 4. And here 0 times negative 1, which is gonna be 0 minus negative 8. And we have another negative here, negative 8 is gonna be 8. And here we have 4 times 0 minus 3 times 2, which is gonna be negative 6. Here 0 times 0 minus negative 1 times 2, so it's gonna be negative 2, negative 2, it's gonna be 2 orally. Here 0 times 3 minus 1 times 4, it's gonna be negative 4. Here we have 1 over negative 2 multiplied by this matrix. Okay, so we multiply it. So here we have a power negative 1 is equal to positive 9 over 2, negative 3 over 2, positive 7 over 2, negative 5, positive 2, negative 4, positive 3, negative 1, and positive 2. And hello everyone, in today's lesson we are going to talk about how to distinguish between linear and nonlinear equations. Everything that can be graphed as a line is considered to be a linear equation. Linear equations are chiefly a straightforward function. They can be upward, horizontal, downward, or vertical, actually. But in the vertical line, the slope is infinite. Actually, it's undefined, so it's not considered as an equation. Linear functions have a constant slope, but nonlinear functions have a slope that varies between points. For instance, here slope is positive. Imagine that it's positive 1. In every point in our line, the slope is positive 1. Okay? In here, the slope is equal to 0, and here the slope is negative. For instance, negative 1. And in every point here, it's negative 1. But in nonlinear equations, the slope varies in points. For instance, here it's negative, here is equal to 0, here is positive, here is 0, here is negative, here is 0, and it changes. And also in here, and they are not a line, so we call them nonlinear. Everything that can be written as y is equal to m times x plus c, or another form is y is equal to c, is considered to be linear equation. For instance, y is equal to 4 times x plus 5, or y is equal to 2. Our equations might contain fractions, decimals, or a square root of a number, or cube root of a number. For instance, y is equal to 1 over 2 times x minus 1 over 10. Y is equal to 0.5 times x minus 1.02. Y is equal to square root of 2 times x plus 2 over the square root of 3. But about the nonlinear equations, if the equation contains exponents, for instance, y is equal to x power 2 plus 5, or y is equal to x power 3 plus 2, it's not considered a linear equation. Actually, it's a nonlinear equation. If we have a square root, cube root, or any kind of root of our variable, the equation will definitely be nonlinear equation. For instance, y is equal to the square root of x plus 3, or y is equal to the cube root of x plus 4 times x. Or if we have more than 2 variables, our equation will definitely be nonlinear. For instance, y is equal to x plus z, or y is equal to x squared plus z squared plus omega squared. Thank you so much for watching. Okay, in this video I want to talk about solving the systems of linear equations by graphing. A system of linear equations contains 2 or more equations. The solution of such a system is the ordered pair that is a solution to both equations. To solve a system of linear equations by graphing, we graph both equations in the same coordinate system, and the solution to the system will be the point where these 2 lines intersecting. Okay, this is gonna be easy because we only have 2 equations. here, and you just need to simply graph them and look for any points of intersection. Also, you can use this method for the system of nonlinear equations. Okay, we have two equations here, y equals x plus 1 and y equals negative x plus 3. We try to find 2 points in each equations. The line that will cross these 2 points is the related graph of that equation, okay? For the first equation, we have y equals x plus 1, and when x is 0, y has to be 0 plus 1, which is 1. So 1 point is 0, 1, okay? And when y is 0, x has to be negative 1, so another point is negative 1, 0, okay? And about our second equation, y equals negative x plus 3, when x is 0, y has to be 0 plus 3, which is 3, so 1 point is 0, 3. And when y is 0, x has to be 3, so another point is 3, 0. Okay, now we try to find these points in our coordinate plane, okay? About the first equation, we have 0, 1, and when x is 0, y has to be 1, and when x is negative 1, y has to be 0, which is this point, and the line that will cross these points is the related graph of this equation, okay? And about the second equation, we have 0, 3, where x is 0 and y is 3, this point. And when x is 3 and y is 0, this point. And the line that will cross these 2 points, which is an individual line, is the related graph of this equation, okay? As you are seeing here, the intersection point is where the x is 1 and y equals 2. 1, 2 is the answer of our system of linear equations. We can also check our answer by substituting it in both equations here and see if it is true or not. And okay, we can check it. 2 equals 1 plus 1, which is true, and 2 equals negative 1 plus 3, which is true again, and the answer is 1, 2. In the previous video, you learned how to find the answer to the system of equations by graphing. In this section, we're going through the other way. A way to solve a linear system algebraically is to use the substitution method. Substitution means we take something and put it in another place. You gotta get any of the 4x and y here by themselves. Here there's a question: solve the linear system using the substitution method. Using this method is only useful when you have a variable, at least a variable with coefficient of 1 or negative 1. For instance, in this example, this x is an only variable with the coefficient of 1. Okay, we have two equations. X plus 2y equals 4. 2x plus 3y equals 5. In the first equation, we try to find this x. Okay, x equals 4 minus 2y. We move it from here to this part. Okay, and the sign will be changed. So, x is gonna be equals 4 minus 2y. And according to this equation here, because we have x now, and we only need to substitute this x in here and plug it in here. 2 times 4 minus 2y plus 3y equals 5. In this equation, we have only one unknown, which is y. And we can easily find it, okay? So we have here 2 times 4 minus 2y plus 3y equals 5, okay? 2 times 4, it's gonna be 8 minus 4y plus 3y equals 5. Negative 4y plus 3y is gonna be negative y, okay? 8 minus y equals 5. Okay, and from here y is gonna be 3. And according to this equation here, by plugging it in here, we can easily find x. Okay, x is equal to 4 minus 2 times y. So x equals 4 minus 2 times 3. Okay, x equals 4 minus 6. So x equals -2 here. And we can also check our answer by plugging it in this equation. Okay, let's check it. 2 times -2, it's gonna be -4, plus 3y, and y is 3, and 3 times 3 is gonna be 9, and overall it's gonna be 5, which is correct. So the answer to this equation is -2 and 3.